This is lesson 2 of chapter 4. It's called Comparing and Ordering Rational Numbers. This is another review from chapter 0, so a lot of this should be very familiar to you. So in your note packet on page 2, the first thing you'll see is a Freyer model for rational numbers. And that's because this is our big vocab word this lesson, and we really want to dive into what a rational number is and how to identify them. So first is the definition. Definition of a rational number is any number that can be written in fraction form. You should recognize this definition from 6th grade and from earlier in the year, but it's really important that we remember it from this point forward. If we can write it as a fraction, then it is rational. Characteristics, these are different types of numbers that can be turned into fractions, so they are rational numbers. Fractions, mixed numbers, whole numbers, terminating decimals, repeating decimals, integers, and percents. So examples of those, I have 4/5, 3.5, 10, 9.5, 0.3 repeating, -11, and 75%. Each of our examples corresponds to one of the words up here in the characteristics. Non-examples. So non-examples are any number that's not rational, and it's not easy for us to think of numbers that are not rational because we don't really use them a whole lot at this level of math. But there is one really big example of a not rational number. We call it irrational, and I want to see if you can come up with it. It is a decimal that doesn't terminate, and it also doesn't repeat. So it's going to continue on and on forever, but it doesn't have any repeating pattern to it. It's a very famous number. I want to see if you can think of that. We'll go over that in more detail tomorrow. So next we have tips to comparing and ordering rational numbers. These are just some suggestions that I have to help make it easier for you. First, I want to make sure that you change all the numbers to the same form. It's really hard to compare a fraction with a decimal if they're not both written in the same form. And I, of course, recommend decimal form because I think it's the easiest to compare. It's also pretty easy to turn any number into a decimal. Remember, too, with ordering negatives, the farther away the number is from 0, the smaller it is. So if you think about the number line, if it's farther down the number line, it's going to be the smaller negative number. Third tip, remember to write your final answer using the original numbers from the problem. That's a big one. And tip number 4, keep your work organized. Our first example problem is example number 1. This is straight from your notes. You are asked to put the following numbers in ascending order. Remember, ascending means least to greatest. The numbers are -3 4/10, 34%, 3, -34 hundredths, and pi. That's the Greek symbol for pi right there. Well, to get this done, the first thing I want to do is I want to change each of my numbers into decimal form. And I'm going to do that right here for you. -3 4/10 is already a decimal. We're going to use D2P to make 34% a decimal. 3 is a whole number. It's already in decimal form, but in order to really kind of emphasize that, I'm going to just write the decimal point after the whole number 3. -34 hundredths is already a decimal. And pi is a really long decimal. It never ends, it never repeats, but we do estimate it to be 3.14. So I want you to really think about that number right there, pi. Next thing we are going to do is we're going to put our numbers in order. So I've got some arrows going on here so you can see what how I was ordering them. But just really quickly, I hope that you notice that negatives are going to be smaller than positives. So my first smallest number is -3 4/10. That's going to be the farthest down the number line. And then is my next negative, -34 hundredths. And then 34 hundredths as a positive, +3, and 3.14. Final part of my problem is to change those numbers back into their original form. This is the step that many students forget right here. They forget to put the numbers back into the original form. You can't get full credit on the problem unless you give me the numbers that I gave you in that order. So please make sure to do that. So my final answer here would be -3 4/10, -34 hundredths, 34%, 3, and pi. Our last example is number 2, comparing compare those numbers using greater than, less than, or equal to. We got 77% and 7/9. Again, those two numbers are not in the same form. I recommend changing them both to decimals. Use D2P to change 77% to 0.77. And then we're going to use division to change 7/9 to this repeating decimal, 0.77777. And I have this 7 right here in red because if you're doing the division, that's as far as you have to go, out to the 4th decimal place, and that's so that we can correctly round our number. So we take that 4th 7 there, that number in the 10,000th place, and we use it to help us round to the 1,000th place. 7 is bigger than 5, so that tells me that I'm going to round up, which puts my rounded answer at 0.778. Now that I'm looking at my two numbers, I can compare them and make it a little bit easier if I add a 0 at the end. And now I can say, okay, that's 770 hundredths. I'm sorry, 770 thousandths, 778 thousandths. So I'm going to use a less than sign. We've got more, a bigger number in the thousandths place in this number than that one. So just a very quick review of what you had to do here. If you are still looking for more examples, I'd like you to look at your Chapter 0 notes. That'll really help you out. And what I want you to do for homework tonight to just complete everything, there are 2 questions that I skipped over in your notes. This is the question after number 1 in the example problem, and it's the question after number 2 in the example problem. So I'd like you to take a look and do those 2 to the best of your ability. I'd also like you to do number 3, write your own problem for this lesson, and then don't forget to complete your Google form. Remember to put any questions that you have in the Google form, and we'll go over them tomorrow.